Good morning, students. Exercise 8.4, problem number 1. Find the magnitude of A vector cross B vector if A vector is equal to 2i cap plus j cap plus 3k cap and B vector is equal to 3i cap plus 5j cap minus 2k cap. Okay, so here what is asked? Find the magnitude of A vector cross B vector. So what is asked? Magnitude of A vector cross B vector. So first we have to find what is A vector cross B vector. Then only we can find the magnitude of it. Okay, so A vector cross B vector. So yesterday, the previous class, that is we have seen how to find A vector cross B vector in terms of rectangular components. So see that A vector is equal to A1i cap plus A2j cap plus A3k cap and your B vector is equal to B1i cap plus B2j cap plus B3k cap. If it's so, your A cross B, how will you write? It is determinant. The first row you will write ijk. In the second row, the components of first vector, and the third row you have to write the components of the second vector. So here that formula only we are going to use. So A cross B, it is a determinant. In the first row I have written ijk, and which vector comes as first, so that component you have to write as a second row. So A vector, the components of A vector is 2, 1, 3. That is I component, j component and k component has to be written. That is 2, 1, 3. And second vector is B vector. So write that components 3, 5, minus 2. And you know that how to evaluate the determinant. You have to expand by R1. So I cap is written and delete the first row and the first column. So you will get the determinant 1, 3, 5, minus 2. You have to evaluate it. So how to evaluate? You have to cross multiply these two elements. 1 into minus 2 is minus 2. In between you have to write minus. Then multiply the subdiagonal elements. 5 into 3 is 15. When you go to the second element of R1, you have to change the sign. So it is minus j cap. Delete the first row and the second column. 2 into minus 2 is minus 4. In between you have to write minus. 3 3s are 9. Plus k cap into, delete the first row and the third column. So you will get this determinant. So it is 2 into 5 is 10. In between you have to write minus. 3 into 1 is 3. So minus 2 minus 15 is minus 17 I cap. And here minus 4, minus 9 is minus 13. So minus 13, here you will have one minus. So plus 13 j cap and 10 minus 3 is 7 k cap. So we have found what it is, A vector cross B vector. But what is asked? Magnitude of A vector cross B vector. So magnitude means it's modulus of A cross B. So how to find the modulus of any vector? So you have to write as a square root of the coefficient of x, the whole coefficient of I cap the whole square, that is x squared plus y squared plus z squared. Your x is minus 17, so minus 17 the whole square plus 13 the whole square plus 7 the whole square. So if you square and add, you will get the answer as square root of 501. So we have found the magnitude of A vector cross B vector. We come to the second problem. Show that A vector cross B vector plus B vector cross C vector plus A vector plus C vector cross A vector plus B vector is equal to 0. Take the left hand side. So here it's a cross product. Here you are having addition. So yesterday we have learned vector product is distributive over addition. We have seen that. You see now A vector cross B vector plus C vector, how it will be written? A cross B vector plus A vector cross C vector. So it is distributive over addition. Using that formula, you have to distribute the vector product to the vectors. So first one, A vector cross B vector plus, next one, A vector cross C vector. The second one plus B vector cross C vector plus B vector cross A vector. C vector cross A vector plus C vector cross B vector. So the first three cross product, you keep it as it is. Come to the fourth one. If you want to, you are going to interchange the vectors a vector and b vector. So a vector will come front, means in the cross product it is not commutative, so you have to write minus. In the same way, if you interchange these two vectors, so it will be minus a vector cross c vector. If we interchange this, it is minus b vector cross c vector. You look at the first one and the fourth one, both are same, one is in plus, another one is in minus. These two getting cancelled. And a cross c, here you are having minus a cross c, both getting cancelled. So here also b vector cross c vector, here minus b vector cross c vector, everything getting cancelled. You have to write 0 vector. Why we have written 0 vector means it's a cross product. Cross product answer is in terms of a vector. So you have to write everything getting cancelled and you have to write it is a 0 vector. Okay, coming to the third problem. Find the vectors of magnitude 10 root 3 that are perpendicular to the plane which contains I cap plus 2 j cap plus k cap and I cap plus 3 j cap plus 4 k cap. You see that two vectors are given. Okay, find the vectors of magnitude 10 root 3 that are perpendicular to the plane which contains. So first you have to take this vector as a vector and this vector as b vector. So now you are having a vector and b vector. So what you are going to find? You see, find the vectors of magnitude 10 root 3. So we are going to find vectors whose magnitude is 10 root 3. Magnitude is given. How the vectors that are perpendicular to the plane containing these two vectors. So which vector is perpendicular to the two vectors means you have mentioned this is a vector and b vector. So which vector will be perpendicular? N cap will be perpendicular to a vector and b vector, as well as a vector cross b vector is also perpendicular to a vector and b vector. Okay, so see now here, yesterday, that is the previous class, we have learned the formula vectors of magnitude lambda which are perpendicular to both a vector and b vector. Vectors of magnitude lambda perpendicular to both a vector and b vector are, we can write plus or minus the magnitude lambda into n cap. This n cap only is a unit normal vector. Okay, so it is a unit vector perpendicular to the plane containing those two vectors. Okay, so here the magnitude is lambda, so lambda into n cap. So what is the formula we have learnt for finding n cap? So it is plus or minus lambda. The formula for finding n cap is a vector cross b vector divided by modulus of a vector cross b vector, because a vector cross b vector only is perpendicular to a vector and b vector. So what you have to find, what is the formula has to be used? Plus or minus lambda n cap, that is plus or minus lambda into a vector cross b vector divided by modulus of a vector cross b vector. So here which word is important? It is perpendicular. So perpendicular means it is the cross product between the two vectors has to be used. So I have written the formula. Here your lambda is what it is? 10 root 3 into n cap. So what is the n cap formula? N cap formula is, it is a vector cross b vector divided by modulus of a vector cross b vector. This is the answer for the question. So in that you have to find a vector cross b vector. How to take the vector product or cross product between two vectors? You have to use the determinant. In the first row, I, j, k. In the second row, you have to write the components of I cap, j cap and k cap. What is it? 1, 2, 1. That is the coefficients you have to write. 1, 2, 1. Next one, b vector coefficients is what? It is 1, 3, 4. So 1, 3, 4. And you have to expand by R1. So you will get the answer as 5 I cap minus 3 j cap plus k cap. And a vector cross b vector, the numerator result we have found. In the denominator, what is asked? Magnitude of that. So magnitude of a vector cross b vector. How to find the magnitude? It is a square root of x square plus y square plus z square. What is x? 5. So the 5 the whole square plus minus 3 the whole square plus 1 the whole square. So if you simplify, it is square root of 25 plus 9 plus 1, that is equal to square root of 35. So what is our answer? It is plus or minus 10 root 3 n cap. N cap formula we have written here. So it is plus or minus 10 root 3. What is a vector cross b vector? Here 5 I cap minus 3 j cap plus k cap divided by, what is the modulus? It's a square root of 35. Okay, so next one, find the unit vectors. Find the unit vectors perpendicular to each of the vectors a vector plus b vector and a vector minus b vector. See, find the unit vectors. How does the unit vectors? Perpendicular. Perpendicular, this word is important. Perpendicular to which vectors? A plus b and a minus b. Okay, so unit vector means it is, you have to find out n cap. Okay, this n cap, how it is? It is perpendicular to what are the vectors? Not a vector and b vector. It is perpendicular to a vector plus b vector and a vector minus b vector. So what you have to do now? So first you write the formula. So we have to find out plus or minus n cap because it's a unit vector. But how this unit vector? It is perpendicular to these two vectors. So first vector is a vector plus b vector cross a vector minus b vector. Because your n cap formula is what? Your n cap is perpendicular to a vector and b vector means it is a vector cross b vector divided by modulus of a vector cross b vector. But in the place of a vector, what you are having now? A vector plus b vector. In the place of b vector, what you are having? A vector minus b vector. So when you substitute in the formula, in the place of a vector, what has to come? A vector plus b vector. In between, what you are having? Cross. In the place of b vector, what will you write? A vector minus b vector divided by the magnitude of it. Okay, so here if you want to use this formula, okay, first what is needed? In this formula, what is needed? You need a vector plus b vector. Okay, what is needed? A vector plus b vector. So here in this problem, what you are having? A vector and b vector. How to add these two? You have to add the same components. So that is I cap plus I cap. What has to come? 2 I cap. J cap plus 2 j cap is 3 j cap. And k cap plus 3 k cap is plus 4 k cap. So I have found a vector plus b vector. In the same way, you have to go for a vector minus b vector. So you can go for the rough work. So how will you write a vector? So write the coefficients. What is it? 1, 1, 1. What is b vector coefficient? It is 1, 2, 3. Okay. So in between, what you are having? Minus. Okay. So you have to change the sign of b vector. So minus, minus, minus. So what is 1 minus 1? 0. 1 minus 2 is minus 1. 1 minus 3 is minus 2. Okay, so we have found the coefficients. We have to write as a vector. So 0 I cap. So you can leave it. Minus 1 into j cap. That is minus j cap. Next, minus 2 k cap. So here it is written minus 2 k cap. So we have found a vector plus b vector and a vector minus b vector. So see this in this formula. What is here? It is a cross product. So this is the first vector and this is the second vector. In between, you have to take the cross product. How to evaluate the cross product? It is the determinant. First row, I cap, j cap, k cap. In the second row, what you have to write? You have to write the coefficients of I cap, j cap, k cap in the first vector. So what is the first vector here? A vector plus b vector. So what are the coefficients? 2, 3, 4. Next one, you have to write the next row. You have to write the second vector coefficients. That is no I cap is there. So therefore 0, minus 1, minus 2. So how to evaluate? Expanding by R1. You see that I cap, delete the first row and the first column. 3 into minus 2 is minus 6. In between you have to write minus. When you multiply these two, you will have minus 4. Already one minus is there. So when you multiply these two, you will have minus. So minus into minus plus 4. Okay. So when you go to the next element, you have to change the sign. So it is minus j cap. Delete the first row and the second column. So what is remaining? 2 into here you are having minus 2. 2 into minus 2 is minus 4. Next in between you have to write minus. 0 into 4 is 0. Plus k cap into, delete the first row and the third column. What is it? First row and the third column. So if you cross multiply, 2 into minus 1 is minus 2. Minus 0 into 3 is 0. So minus 2, minus 0. Okay. So when you evaluate, it is minus 6 plus 4 is minus 2 I cap. Here minus 4, minus into minus plus 4 j cap. Here when you calculate, it is minus 2 k cap. What we have found? We have found the numerator. What is in the denominator? The magnitude of the numerator. So magnitude means what you have to write? You have to write the, how to write the magnitude? Magnitude is a square root of x squared plus y squared plus z squared. What is x? It is minus 2. That is the coefficient of I cap. Minus 2 the whole square plus 4 the whole square plus minus 2 the whole square. So it is 4 plus 16 plus 4. That is equal to square root of 24. So you have to substitute in this formula. So unit vector perpendicular to a vector plus b vector and a vector minus b vector is. So see that it is plus or minus. You have to write this vector. What is it? Minus 2 I cap plus 4 j cap minus 2 k cap divided by modulus of this. So the magnitude of this is square root of 24. So it is written square root of 24. The square root of 24, how you can write? It is 4 into 6. What is square root of 4? Square root of 4 is 2. Okay. So 2 into root 6. Square root of 24 is 2 into root 6. Okay. Here from this term I have taken minus 2 out. So what is remain here? I cap minus 2 j cap. From this minus 2 is taken out. If minus 2 is taken out, here what you are having? I cap minus 2 j cap plus k cap. Okay. The plus 2 and this 2 getting cancelled. So minus into plus, plus into minus, you will have minus. Minus into minus plus. So you can write it is plus or minus I cap minus 2 j cap plus k cap divided by root 6. Okay. So coming to the problem number 5. Find the area of the parallelogram whose adjacent sides are determined by the vector. See what you are going to find? You are going to find the area of the parallelogram. Area of the parallelogram. What is given? Adjacent sides are nothing but the first vector and the second vector. So the first vector has to be taken as a vector and the second vector has to be taken as b vector. These two vectors are adjacent sides of the parallelogram. What is asked? Area of the parallelogram. So what is the area of the parallelogram? It is nothing but, you see that, area of the parallelogram. In the geometrical meaning of vector product, we have arrived. Area of the parallelogram OA, BC. In the OA, BC, OA vector and OB vector are, they are the adjacent sides of the parallelogram. Means what is the formula here? It is used modulus of A vector cross B vector. So to find the area of the parallelogram with A vector and B vector or adjacent sides, the formula is, it is a modulus of A vector cross B vector. So to find the magnitude, first we should know what is A vector cross B vector. How to evaluate the vector product between two non-zero vectors? It is a determinant. In the first row, I, J, K. In the second row, the coefficients of I cap, J cap, K cap of first vector. So what is A vector? It is I cap plus 2j cap plus 3k cap. What are the coefficients? 1, 2, 3. Here 3 minus 2, 1 are the coefficients of the second vector. So you have to evaluate. When you evaluate, you are getting 8i cap plus 8j cap minus 8k cap. If 8 is common, if you take it out, it is I cap plus j cap minus k cap. And here this is the vector area of the parallelogram. So because area is in terms of a vector. Here what is asked? Not vector area, it is asked area of the parallelogram. So you have to find the magnitude. So the magnitude of this vector. Here 8 is a number. So the modulus of 8 is 8. And the remaining is a vector. How to find the magnitude of the vector? It's a square root of x squared plus y squared plus z squared. So that is 1 plus 1 minus 1 the whole squared. So therefore, here when you evaluate, it is 1 plus 1 plus 1. So it is root 3. So 8 root 3 square units. That is the area of the parallelogram. Okay. So we'll come to the problem number 6. Find the area of the triangle whose vertices are. See that the previous problem you are having, what is it? Vectors whose adjacent sides are it is given. But here find the area of the triangle. And vertices are given. So vertices are nothing but the points. If the points are given, you have to take the position vectors. So first, from the first point, you can write OA vector. What is OA vector? 3i cap minus j cap plus 2k cap. From the second point, the next position vector is OB vector. That is I cap minus j cap minus 3k cap. And the third one, from the third point, you can write OC vector. OC vector is 4i cap minus 3j cap plus k cap. Okay, 3 position vectors are given. So what is the area of the triangle? If you have two sides, area of the triangle, if you have two sides, it is half into modulus of A vector cross B vector. In the previous class, we have learned area of the parallelogram with A vector and B vector or adjacent sides means it is modulus of A vector cross B vector. Area of the triangle with A vector and B vector or two sides means it is half into modulus of A vector cross B vector. Here we need the side. How many sides we need? 2 sides. So that's why we are going to find AB vector. AB vector is one side. Okay, that is how to write AB vector. Using position vector, you can write OB vector minus OA vector. Okay, so see that in the rough work, OB vector, write the coefficients OB vector 1, minus 1, minus 3. Okay, that is the coefficient of OB vector. Next, OB vector minus OA vector. What are the coefficients of OA vector? That is 3, minus 1, 2. And in between what you are having? You are having minus. So, change the sign. Okay, so here you will have this is minus. Here this will become plus and here you will have minus. Okay, so 1 minus 3. What is it? It is minus 2. And minus 1 plus 1 is 0. Minus 3 minus 2 was minus 5. So write as a vector. So minus 2i cap minus 5k cap. Next side you have to find. What is it? It is BC vector. Position vector when you use, how it will be written? Position vector of the second point minus position vector of the first point. So therefore OC vector minus OB vector. So here first vector is what? OC vector. Write the components in the rough work. So 4 minus 3 1. And next what here you are having OB vector. Write the coefficients. It is 1 minus 1 minus 3. So what you have to do? You have to change a sign because in between you are having minus. So you have to change the sign. This will become minus. Here you will have plus and this also plus. Okay, so after changing the sign, you do the calculation. So 4 minus 1 is 3. Here minus 3 plus 1. Minus 3 plus 1 is minus 2. Okay, so 1 plus 3 is 4. So we got the coefficients. If you write as a vector, 3i cap minus 2j cap plus 4k cap. Now what you are having? You are having two sides. What is the first side? AB vector. What is the second side? BC vector. If the two sides A vector and B vector, means the formula is half into modulus of A vector cross B vector, because it is the area of the triangle. So you have to use half into modulus of A vector cross B vector. What is your A vector now? That is your first vector, that is AB vector. What is the second vector? That is BC vector. So you have to take this is the formula you have to use in this problem. So AB vector, BC vector is there. First you have to find the cross product. So the cross product evaluation is a determinant. In the first row I, J, K. In the second row what you have to write? You have to write the coefficients of AB vector. So therefore minus 2, 0, minus 5. And the next row you have to write the coefficients of BC vector, that is 3, minus 2, 4. And if you evaluate, you will get the answer in terms of a vector. So what's a vector here? You are getting minus 10 I cap, minus 7 j cap, plus 4 k cap. And here in this formula, what is it? It is a magnitude is asked. So we have to find the magnitude of this vector. So it is a square root of x squared plus y squared plus z squared. What is your x? Minus 10. So minus 10 the whole square plus minus 7 the whole square plus 4 the whole square. If you calculate, your answer is square root of 165. So we have found the vector and its magnitude is also fine. So we have to substitute in the formula. What is the formula? Area of the triangle with A vector, B vector or two adjacent sides in this problem, half into modulus of AB vector cross BC vector. You should not forget the half. So half into, what is the modulus? It is a square root of 165. So the answer is half into square root of 165 square units. And coming to the problem number 7. See, if A vector, B vector, C vector are position vectors of the vertices, they are the position vectors of the vertices. What are the vertices? A, B, C of a triangle ABC. Show that the area of the triangle, what is asked? Area of the triangle ABC is this one. Also deduce the condition for collinearity of the points ABC. Okay, see now, here it is given position vectors. So this A vector is the position vector of the point A. So it is OA vector is equal to A vector, OB vector is equal to B vector, and OC vector is equal to C vector. So position vectors are given. So to find the area of the triangle, we need the sides. We need two sides. So here first side is AB. It is written in terms of vector. So AB vector. And the second side is BC vector. How to find the AB vector? If position vectors are given, that is OB vector minus OA vector. What is our OB vector? B vector. What is our OA vector? A vector. And BC vector, how will you find? OC vector minus OB vector, substituted. Okay. So what is the formula to find the area of the triangle? Half into modulus of A vector cross B vector. Here in your problem, AB vector cross BC vector. You just write AB vector. What is it? B vector minus A vector. Cross BC vector is A vector minus A vector. So here you are having cross product. In between it's a subtraction. So vector product is distributive over subtraction also. So while you are writing, you have to be careful. Take the first vector and distribute to the C vector. So B vector cross C vector. Next, you should not change the order. B vector cross minus B vector. So what is it? You have to write. How will you write? It is B vector cross minus B vector. So this minus, so it can be written as minus 1. It's a constant. So if in the cross product, if the constant come, we can take the constant out. So minus 1 into, how we can write? B vector cross B vector. So that can be written as minus B vector cross B vector. Okay. So see that I have written minus b vector cross b vector. Okay, first vector we have completed. Take the next vector. Here you are having minus. So minus a vector cross c vector can be written as minus of a vector cross c vector. And the next one, minus a vector cross minus b vector. So what is here? Minus a vector cross minus, you will have minus b vector. Minus b vector. So here minus into minus, it's a minus 1 into minus 1. It's a constant. So minus 1 into minus 1 is plus 1. So therefore you will get a vector cross b vector. We didn't change the vector. Okay. So we'll multiply the constant. So you are getting the 4 results. And you see that b vector cross b vector is a 0 vector in the cross product. If any two vectors are same, the cross product is equal to 0 vector. Because in the cross product definition, you will have a vector cross b vector. How will you write? How it is defined? Modulus of a vector, modulus of a vector, sine theta. So here the two vectors are equal means the theta is equal to 0. So sine 0 is 0. So n cap irukradanaala you have to write 0 vector. Already I have explained this. So in the cross product any two vectors are equal, the answer is a 0 vector. And here you are having minus. So if you interchange the vector, so a vector is first and here c vector as second vector. If you interchange, you will get 1 minus. So minus into minus plus c vector cross a vector plus a vector cross b vector. So half into, you just write this first, this because here you are having plus. So we can rearrange this, a vector cross b vector plus b vector cross a vector plus c vector cross a vector. That is the area of the triangle. We have proved the result. And what is the second one is asked? From that you have to deduct the condition for collinearity of the points. You see that if the 3 points are lie on the line, we can't draw a triangle. You see now here A, B, C. They lie on the same line means, okay, can you draw the triangle using these 3 points? No. So if you can't draw the triangle means the area of the triangle is 0. So if the 3 points are collinear, or then the area of the triangle is 0. So here we have found the area of the triangle. So it should be 0. Okay. So the half, when you take to the next side, it will become 0. So this is the condition for the 3 points to be collinear. Okay. So the next one, 8th problem. For any vector a vector, prove that modulus of a vector cross I cap the whole squared plus a vector cross j cap the whole squared plus a vector cross k cap the whole squared is equal to 2 into modulus of a vector the whole square. So first a vector we have to consider for any vector a vector. So here my a vector is a1 I cap plus a2 j cap plus a3 k cap I have taken. Okay, take the first result. It is written within the modulus. In the place of a vector I have written this cross I cap the whole square. It is a vector product here. Here you are having plus. So vector product is distributive over addition. Take the first vector. A1 I cap cross I cap. So it is A1 I cap cross I cap. A1, A2 or A3 or the coefficients, they are constant. So next one, A2 j cap cross I cap plus A3 k cap cross I cap the whole square. So it is a same vector. So the cross product of the same vector is equal to 0 vector. Okay. So what is j cap cross I cap? So in the previous class we have discussed about it. You see now it is j cap cross I cap. So I have told the result I cap cross j cap is k cap and j cap cross k cap is I cap and k cap cross I cap is j cap. I have told. So if it is in the cyclic order you have to write positive. If it is not in the cyclic order you have to write minus. Okay, so in the previous class we have discussed about that. You just go through that property and write here j cap cross I cap. Is it in the cyclic order or not? No. Cyclic order means I j has to come, but here it is j cap cross I cap, so it is nothing but minus k cap. And here k cross I, it is in the cyclic order, so it is j cap. Okay, so 0 vector a1 into 0 vector is 0, so you will get this. So in the you have to find the magnitude. So how to find the magnitude of this vector? It's a square root of minus a2 the whole square plus a3 the whole square. In the magnitude, the whole square means this whole square I have written. So the square and the square root getting cancelled. You are having a2 the whole square minus a2 the whole square is a2 the whole square plus a3 the whole square. So take the next term the same way. You have to substitute in the place of a vector as this. And it has to be vector product is distributive. When it is distributive, what is I cross j? It is in the cyclic order, so it is k cap. So it's the same vector, the cross product is 0 vector. K cross j, which one has to come? I, j, k. Okay, here k cross I is there. It is not in the cyclic order, so minus I cap. So you will get the vector. So you have to take the magnitude. So magnitude means it is nothing but the square root of, what is it, a1 squared plus a3 minus a3 the whole square. So square of the magnitude, so here you have to return as square. So the square and the square root getting cancelled, you will get this answer. Okay, in the same way take the next one. Substitute in the place of a vector as a1 I cap plus a2 j cap plus a3 k cap. So you have to distribute. So when you distribute, you will get this vector. So you have to take the magnitude, then you have to take the square of it. So you will get a1 square plus a2 square. So here in this problem, what we have to prove? We have to add all the three terms. So just add the results of the first one, second one and third one. What is the first one? It is a2 squared plus a3 squared. Here also you are having, you see now a2 squared is there. About 2a2 squared plus 2a3 squared and 2a1 squared. So if you take 2 out, what is remaining? So you will have 2 into what is that? a1 squared plus a2 squared plus a3 squared. That is nothing but modulus of a vector the whole squared. What is a vector? So your a vector is, what is your a vector? It is, we have taken as a1 I cap plus a2 j cap plus a3 k cap. Okay, what is the magnitude of a vector? So it is a square root of, what has to come? X squared plus y squared plus z squared. Okay, so now what you have to take? You have to take the square of it, modulus of a vector the whole square. So it's a square root of a1 squared plus a2 squared plus a3 squared the whole square. So in the square and the square root getting cancelled, you will have a1 squared plus a2 squared plus a3 squared. So that's why here we have written it is nothing but modulus of a vector the whole square. So we have proved the result. And coming to the problem number 9, you see that let a vector, b vector and c vector be the unit vectors such that a dot b is equal to a dot c is equal to 0, and the angle between b vector and c vector is pi by 3. Prove that a vector is equal to plus or minus 2 by root 3 into b vector cross c vector. What is the first result given? They are unit vectors. So if they are unit vectors means whose magnitude is 1. So modulus of a vector is equal to modulus of b vector is equal to modulus of c vector is equal to 1. And what is the next result given? A dot b is equal to a dot c is equal to 0. What is a dot b equal to 0 means? A dot b is equal to 0 means dot product of two vector is 0 means this a vector is perpendicular to b vector. Okay, and in the side one more result is also given. A vector dot c vector is equal to 0. So the dot product between these two vectors is 0 means your a vector is perpendicular to c vector. Okay, so now how is your a vector? A vector is perpendicular to b vector and C vector. So suppose if you are having, see, this is your B vector. For example, for rough work, this is your C vector. This is your C vector. And how is your A vector? Your A vector is perpendicular to B vector and C vector. Okay, already we know that B vector cross C vector, it is also perpendicular to B vector and C vector. So, if you take the cross product between any two vectors, that cross product of the vector is perpendicular to the given vector. So, B vector cross C vector is also perpendicular to B vector and C vector. How these two, B vector cross C vector and A vector, how they are? They are parallel. So, that concept only we are going to use here. See, from this result, we conclude A vector is perpendicular to both B vector and C vector. Okay, and already we know that B vector cross C vector is also perpendicular to B vector and C vector. So therefore, when you compare A vector and B vector cross C vector, they are parallel. If they are parallel, we can write one vector is a scalar multiple of other. So A vector is equal to lambda, that is a scalar, into the other vector is what? B vector cross C vector. Here if it is in the same direction means you have to use plus. If it is in the opposite direction means you have to use minus. So that's why here I have written plus or minus. So one vector is a scalar multiple of other vector, taking modulus on both the sides. So it is modulus of A vector is equal to modulus of plus or minus lambda into B vector cross C vector. So lambda is a scalar, so it is a plus or minus lambda into modulus of B vector cross C vector. So modulus of A vector is equal to, when you take the modulus, plus and minus will become plus. So here you will have lambda. So what is the modulus of B vector cross C vector? Use the definition. So it is modulus of B vector, modulus of C vector, sine theta. So what is the angle between B and C? In this problem it is given angle between B and C is pi by 3. So now your theta is equal to pi by 3. And we know that they are unit vectors, so whose magnitude is 1. So here modulus of A vector, in the place you have to write 1. And here you are having lambda. Here also 1 into 1 into sine pi by 3, sine 60 degree. What is sine 60 degree? That is root 3 by 2. So when you multiply lambda into root 3 by 2. So when you bring it to the left side, it is 2 by root 3. So lambda is equal to 2 by root 3. So where you have to substitute in the first result, A vector is equal to plus or minus 2 by root 3 into B vector cross C vector. So we have proved the result. And coming to the 10th problem, find the angle between the vectors. Angle between the vectors. Okay, first vector and the second vector is given using vector product. So they have mentioned using vector product. Okay, so first vector is taken as A vector and the second vector is taken as B vector. So the formula to find the angle is sine theta. Why I have used sine theta means using vector product is given. So that's why we have taken sine theta. If the angle, find the angle between two vectors, which is give the correct angle if you use dot product. But here it is mentioned vector product, so we have to use this formula only. So the formula is sine theta is equal to modulus of A vector cross B vector divided by modulus of A vector modulus of B vector. So for this, first we have to find A vector cross B vector. Then only have to take the magnitude. So A vector cross B vector, how will you find? You have to use the determinant. First row I cap, j cap, k cap. In the second row the coefficient of A cap, A vector. And the third row you have to write the coefficients of B vector. And if you expand by R1 you will get this answer. Here 3 is common. If you take it out it is I cap minus j cap plus 2 k cap. So A cross B is found. Then in this formula what is asked? Magnitude. So magnitude of A cross B means it is a modulus of this vector. So modulus of this vector. Modulus of 3 is 3 And how to take the magnitude of this vector? It's a square root of x square plus y square plus z square. So that is, everything is 1 here. If you add 3 ones, it is root 3. So 3 into root 3. Magnitude we have found. Next, what is asked? Magnitude of a vector. So a vector magnitude has to be found using the same formula, square root of x square plus y square plus z square. That is root 6. In the same way, modulus of b vector. So it is a square root of 1 square plus 2 the whole square plus 1 square. So it will be root 6. So substitute in the formula, sin theta is equal to modulus of a cross b. Modulus of a cross b is what? It is 3 root 3. It is substituted. Divided by, in the formula, what is here? Modulus of a vector, that is root 6. And modulus of b vector also root 6. Root 6 into root 6 is 6. 3 and 6 getting cancelled. So root 3 by 2. Sine of which angle having root 3 by 2 value? So sine 60 degree. So sine pi by 3. So when you compare, theta is equal to pi by 3. So using vector product, the angle between the two vectors is equal to pi by 3. Thank you, students.